Hi, today we're looking at a unique LED bulb by Feit Electric. Take a look at the number right on the bulb here. Let's turn it off, it'll be a little easier to see on camera. Right there. 1500K color temperature, 35 lumens, and it's a flame effect bulb with a small base on it. I'm running an adapter, as you can see. Very unique bulb internally. We'll take a look at the chips it uses and how it works internally. Let's plug this in while we've got this here. Take a look. It's rated at 2 watts. It's coming in at 1.5 on the kilowatt meter. Cool decorative bulb. Does have a orientation sensor. Let's see if that shows up on camera. A little bit subtle. When we pop this lid off, you'll be able to see the orientation sensor. There it goes. It flipped already. Uses a mercury tilt. We'll take a look at that. I'm surprised they're using that nowadays. Let's look at the specs real quick on the website, and then we're going to pull this thing apart and see how it works internally. On the website here, we've got nothing too special. Claiming 15,000 hours. It's a 120 volt bulb. 1500 on the color temperature. Uses 2 watts. Candelabra base. Warranted for 2 years. Alright, let's see what we've got. This one is rather unique. Not only in performance, but the way it works internally. What they had to do first was give it a 5 volt clean power supply, just as you would have on your phone, for example, for charging, or on a lot of devices. A lot of bulbs don't need that and don't utilize it, but this bulb is different. This basically has a computer chip on it and needs some clean voltage. In this case, they're using the 5 volts for everything to power the LEDs, as well as run the little CPU that it has. This is your power supply board in here. Let's take a look, point out a few things that we can see. You can see how the power comes in on those 2 leads, and it goes through a fuse. It's that little blue package there. That's a fuse. It's nice to see. There's a couple of capacitors here. They're 200 volt 4.7s, and here is the output filter cap at 1,000 micro at 10 volt. Pretty robust. And then there's a couple of filter chokes, and the power comes in. It goes through a full wave bridge rectifier, which is right here, and that basically is going to take your 120 volts here in North America, and it turns that into DC, and then they filter it, and that'll boost you up near 170 volts, 165 to 170 volts. And then what they do is they run it through a rather unique chip that's here for an LED bulb. Let's take a look at the spec on the chip. That chip is what makes this makes this all happen. And I think we got a PDF for that. Let's bring that up. There we go. Alright, so what that chip does, all in one chip. Really cool that they have it that way. It's called a BP2513D. It's a non-isolated CCCV driver, constant current, constant voltage driver IC. Suitable for 85 to 265 volts, so they could use it in Europe as well on European voltage. And it uses 500 volt MOSFET with constant current and constant voltage, as we said. High efficiency. There's some specs if you want to. You can always pause and read them if it's. We're not going to go through all of that, but Standby power less than 200 milliwatts. Pretty efficient. This is a general schematic of how it would be used, and that's pretty much how they're using it within the Feit bulb here that we're looking at. Here is your full wave bridge rectifier. They're showing it as discrete diodes. AC in is here, and then it goes through those two 470s, excuse me, 4.7s at 200 volts. They just show one cap here. Some ancillary components. The main chip here is basically taking the 167-ish, 65, 170 approximate, depending on your line voltage, DC, and it's giving you an output of 5 volts right here. Here's the filter cap. Internally they're using 1000 mic at 10 volts because it's happens to be a 5 volt output. So depending on what resistors you use and so forth on this particular BP2513D, it'll give you a fixed constant current, constant voltage output. In this case, 5 volts. And it's rated, let's see here, 0.45 watts is the power dissipation on it. So it's not a huge power device by any means, but you don't need much for an LED bulb. Maximum operation frequency 100 hertz, 100 kilohertz. Yeah, so pretty neat chip. And that's how this thing gets the line voltage, even up to 240 or 265, down to 5 volts DC, which is needed for the second board. Let's take a look at that one. And that one here is these white wires is your 5 volt out. And it's clean, 5 volts DC, nice clean power. And then it goes into this circular board here, which is your business end of the light. There's 96 LEDs, 12 on each of the 8 surfaces, and you can see how, when I was talking about in some other videos, you could just tell by looking at the LEDs, the oranger they are, the warmer they're going to be. These are especially orange, giving you the 1500K color temperature. So very, very deep, rich, orangey yellow light. That's what you want for a flame. And it's interesting that they use so many of these. That's what they do on these flame bulbs. Rather than using maybe some brighter ones with 360 light pipes, maybe 4 of them going up, but they don't do it that way. They use multiples. And the way it works is, we'll plug it in and look in a second here, is the bottom 3 or so are on all the time for the base of the flame, and then they modulate, say, the next 2 or 3 LEDs, the next 2 or 3 LEDs, the next 2 or 3 LEDs, and that gives you that flame effect. But I notice it's not the same exactly on all of these planes. So it's interesting how they did it. This is your controller IC here, which controls basically these transistors on the base here. They're broken up. Looks like there's about 3 of them per segment. 1 transistor per side. Well, 3 transistors per side. So the bottom ones are on all the time, and then they break the remaining LEDs up into 3 sections. 1, 2, 3 transistors. Here they've got 4 of them on this side, but 2 of them here, and then 3 on this side and 3 on this side. So basically this chip is controlling the transistors, which turn the different segments of LEDs on to give you the flame effect. Rather interesting. Now if you notice, here is a mercury tilt. The old-fashioned mercury tilt. And there's a little bubble of mercury in there, and that's the orientation sensor. Here it's going to be open, normally open, and then when the mercury falls down on the 2 pins in the glass envelope there, it completes the circuit and it says, okay, we're in this orientation. Or it opens the connection and says we're in this orientation. Interestingly, they make a larger bulb, which we're going to look at in another video, that has an orientation sensor, but it has a ball bearing and some contacts inside. So it's interesting why they used it. Mercury tilts have been around for a long time. They handle a fair amount of current because of the surface area and the conductivity of the mercury. You know, thermostats, that's how they all worked with mercury tilts back in the day on a bimetal spring. That's why you had to put a level on them and make sure they were level for accuracy. Nowadays we use thermistors in the thermostats. More accurate. So it's kind of neat to see the old mercury tilt in there. Let's plug this in. They have a insulator. Pretty important. If you don't put that in, you're going to have line voltage. You're going to blow this thing up. Would blow the fuse and permanently damage this bulb for sure. So that's important to put that in there, because that gives you your insulation between the two. And we are going to, yeah, let's clip that in place. Let's plug this in. We'll take a look at the flame effect. Let's take a look here. So it kind of gives you an idea. Now with the rolling shutter, it's going to be deceiving. See, on the camera it looks like those bottom ones are turning on and off. Now to the visible eye they are not, but they're obviously being pulsed. So the camera shows them as pulsed. So the only way to really get the full effect of this bulb is to see it in person, is to buy one. But I can tell you that the bottom three LEDs all along the bottom to the naked eye, well, they do pulse a teeny tiny bit, and then as you go up, the next three pulse even more, and then the next three actually physically turn on and off, that you can pick up, and then the very top three are flickering on even less, and that's how they're achieving it. Now if we take a look, you can see there's a difference between these here on this plane and these on this plane. They're not doing the same thing. So it looks to me, I'm trying to see how many different effects there are, how many different planes, or are they just doing the same thing? Okay, so these two are doing the same thing. These two are not doing the same thing here. These two are doing the same. And these are not doing the same effect. So they've broken it up to make it, I guess, as realistic as possible. Now, it really doesn't look realistic without the diffuser on. You put the diffuser on, and that really gives you a nice effect. And again, you lose some of it with the camera, with the rolling shutter and so forth. But it looks pretty good. And the orientation sensor, see, the base of the bulb is lit more than, say, the top of the bulb, and then when you flip it, that just flips over. Now this part of the bulb stays on, and these pulsate more, depending on the type of fixture you have. So neat little bulb. That's how they achieve it, the effect. And we're going to look at one that's just scaled up. It uses a standard large base, and it's you know, probably twice as tall. Has about the same amount of LEDs, and but uses light pipes, a lot of neat light pipes, and the frosted dome on it's about the size of a, I don't know, a can of Coke, I would say. So kind of neat technology. So these are nice. You can put them, you know, you can put them in the living room. You can leave them on. If you left this on 24/7, say you're paying the average U.S. rate, this would cost you about $1.50 a year to run. I did the calculations. So and that's 24/7. So if you put it on a timer and it only comes on at night, for example, you know, half of that. and they're just like a nice comfy glow. I do like them. So thanks for tuning in. We are a new channel. We don't get any type of compensation by any vendors of any sort. So if you like the video, give it a thumbs up and subscribe to the channel. Hit the bell and you'll be notified of new interesting electronic products, not necessarily LED based, but some of that. But anything Internet of Things and electronic based. Thanks for watching.